Moving into the scene managers themselves, this is going to be fairly rapid fire since a lot of them share quite a few similarities. The most notably, a lot of them will have a map of, okay, if we move into the drawable manager, we'll see we have a list of drawables and we just run through them and call draw on all of the registered objects that we have. So that's going to be the fairly common theme here. So since we're here, let's talk about the drawable manager. It has two functions: process elements, where it calls draw, the regular draw, so 3D, and then process 2D elements, where it calls draw 2D, such as sprites. We have register for registering to the list. We also have a list ref so that we can use it during the deregister for fast deregistration. And that's the only time I'm going to mention it because every single manager uses this style of getting a reference for the iterator and then handing it in so that we can quickly delete it. If we go into the CPP, it's fairly straightforward. Insert, erase, we clear at destruction, and as I said, we simply loop through the list and call draw or draw 2D. Moving on, we're going to go into the update manager since that's also fairly straightforward. Again, list ref, we have process elements, and we have a list of all of the updatables. Again, nothing too interesting. We simply call update on all of the objects that we have every time process elements is called. And just to reiterate, process elements is called during the appropriate stage, so update, it's called then, or for the draw manager, it's called there. We will also go into the visualizer attorney later on. That's going to be after all of these scene managers. So, let's go into the alarmable manager now. This one is a little different since we have multiple alarms for every single object. So, we have the alarm, the standard map is the timeline map. We have the time, and then we have the alarm event. And the alarm event is alarmable number and the ID that it has. So, we know, okay, how far away is it, which object it is, and what alarm to call. We have the static const number of alarms. We can change it, but we would have to then change the enum as well, and then also change the alarm in the game object, but for now, we only have these three alarms. Moving on, we have process alarms, which is, processing, checking them to see if it's relevant. Register, we have the time, this object, alarm ID, and again, list ref for fast deregistration. Moving into the CPP file itself, every time the register is called, we get the total time, and we edit the time handed in to convert it into how long it's been since the game started as a whole. So this way the user can say, I want it to activate 3 seconds from now, and we can automatically convert that into the engine time and be like, okay, that's this relative amount of time, and then we insert it into our timeline. The register, nothing new, but the process alarms, we get the time, and then we compare the first alarm to that time. So you'll see r.first is less than total time. That basically just says, because we know the timeline map is going to be ordered by the time. So if the time has not elapsed for the first alarm, it will not have elapsed for any of the alarms. So we just go through that, and then if it's time, we trigger the alarm with the appropriate calls, we remove it from our list, and then we check the next one. Fairly straightforward. The camera manager has all of the camera management functions. It has 3 default cameras technically. The default 3D camera, default 2D camera, and then a God camera. This is more of a debug tool than an actual default, but it's initialized on startup, so it is a default camera. And then we have a God Cam Manager, which we'll talk about in a bit. So the get camera, we have get 2D camera, set current camera, set God camera is current, set default is current. There's not much here. These are all the scene has pass-through functions. If we go back, you can see set default camera, and we simply call the cam manager's version of that. So all of the camera management happens within this file. So speaking of, let's go into the CPP. We set up all the cameras when it starts up, and we set the current camera to the default 3D camera. We have some information functions. We make a new God Cam Manager if we don't already have one, and then when we terminate, we delete everything. So the God Cam Manager simply controls the God Cam. We have all of our initialization functions, and this is a game objects because we need to track key inputs. So we have key held down, and that's the only method that we really care about. We have a ton of input registrations, which we'll also get into. Some initialization, and then when we get the key held down, we will find out what key has been pressed, and then rotate the camera accordingly. And this has a ton of math. And then at the end, we update the camera. So that's basically how the God Cam is controlled. The user doesn't need to make this game object. It's automatically handled for them, and it's automatically deleted when the time is right. So that's that. Moving on, we are going to be talking about inputs now. Since we have this, it's a good segue. The high level is the keyboard manager, which doesn't actually look at any of the keys itself. It has a map for every key, and then a single key event manager, which we will get into in a bit. So every key gets its own key manager, and that key manager tracks all events related to that specific key. And it's important to note that we only have key event managers for keys that have been registered for. So for the register, we have the object, the key it wants, what type of event, and then a reference. And then for deregister, we do need, it's not just the reference, we also need the key and the event type still, so that we know, okay, they want to deregister for this key in this event, and not, maybe they want to keep another key, or the same key but a different event. And then we have process key events, which calls, if we go in here, we can see it simply calls the process key event for all of the key event managers. It doesn't handle it itself. And again, if they're registering for a key and there's no manager, then we just make a new one and we tell it, okay, this is what's been registered. And when the time is right, we delete all of the key event managers. So let's go into the key event managers, and this is what we have. So we have 4 different lists. We have press list, held down list, release list, held up list. This is simply corresponding to the different event types that you can register for, which are shown here. So the key event manager has 4 different lists so that an object can register for multiple events on the same key. It can be present in multiple of these lists. We have the key that we're watching, the current state it's in, which is either up or down, and then we have the register, not much to see here, and then the deregister, which again we have the event type, and then the references for the quick delete. Moving in, you can see that when we register, we find out what type of event type that the object wants and put it into the corresponding list, and if somehow it gets here, then we throw an assert error. Deregister is the same way, find out which event it wants, and then erase it quickly from that corresponding list, and throw an error if somehow it gets gamed and something goes wrong. Process key events is a little interesting though. We get the key state for the current key. So we check the state whether it's up or down. And then we compare it to what we have stored, which is what it was last frame. So this way we can tell, okay, so it is currently down, but we have it stored as up. So it was pushed down this frame, so we will call key pressed on all of our objects. Or, oh hey, it is down and it is still down, so we'll call key held down on all of our events. And the same goes down here. It's a bit messy with two if statements for every key event, but we have to check the keys, so it's a little unavoidable. Next episode we'll go into the collisions and then move on from there.